Hello everyone. So today we are going to see the Leetcode POD and the problem is count number of nice subarray. So the problem statement is given an array of integer nums and integer k. A continuous subarray is called nice if there are k odd numbers on it. We have to return the number of nice subarrays. So this was the problem statement and examples are given here. So example for in the first example it is given like nums is given, nums array is given and k value is given. So we have to find out continuous odd k odd numbers and yeah, we have to find out uh, the number of nice subarrays. So here there are two nice subarray because we have to take three odd numbers from. So when we are going from zero position to means the third position, zero to third, then we are getting one, and after that one to one one means from first position to the fourth position. Then also we are getting the another subarray which is holding three odd numbers. In the second example, when we have to choose one odd, then we will search inside nums that how many consecutive k odd numbers are present. So this is an even number and 4 and 6 are also even numbers. So there are no odd numbers in the array. So the value will be 0. And when we are going for the third example and we are searching for k is equal to 2, then here we can see this subarray is containing two odd numbers, 1 2 2 1. Subarray is containing two ones, and whenever this subarray is getting added with another subarrays, those will represent those will also be nice subarray. So let's suppose when we are starting from here to here, it is also a subarray which is having two consecutive two odd number inside that subarray, not consecutive odd numbers. Here we have to find that a continuous subarray which is having k odd numbers inside it. So this is a subarray which is having two odd numbers. This is also a subarray which is having two odd numbers. Similarly, this also have two odd numbers, and obviously this is having two odd numbers. After that, similarly when we are having all those previous number and the subarray which holds the two odd numbers, and with this when we are going with the previous all these numbers, these are giving us the number of subarrays. Similarly, the behind numbers will also give the subarrays, and when we are counting these subarrays, including these subarrays, then the combination of those number of subarrays will be counted inside the nice subarray. So we can see like from here to here, this is a subarray which will be counted as nice subarray. This will also be counted as nice subarray, and the whole one will also be counted as nice subarray. Similarly, when we are going to count for this one, or if we are going with this one, this will also will get counted as the nice subarray. So we see that whenever the minimum length of subarray which satisfied the number of odd numbers, and uh, for with which if we are applying all the previous elements which are not odd and the next elements and all those combination, then we are going to get total number of nice subarrays. So okay, so we can see like we have to go with two pointer approach here, because we have to take care of like first pointer here, and then we have to take care when we are going to get the total k number of odd numbers, and then we are going to count that as subarray, and then we are going to minimize the first pointer and then minimize and again minimize, and after that whatever the number of subarrays which are coming later on, those will be counted with all the numbers which have come earlier. And yeah, that's how we are going to solve this problem. So let's check the constraints. What are the constraints? Here the num's length is from 1 to 5 50,000, and the value inside nums is varying from 1 to 10 to the power 5, and k can be from 1 to the 1 to the length of the nums. Yeah, so let's go with the code. So n is equal to nums dot length, and we are going to take care for the number of subarrays count, and then number of odds. Initially it will be 0, and then int j is equal to 0, and we are going to go with a pointer I inside nums. And if the current number is odd, then we are going to increase the number of odds. And yeah, while odd is equal to k, we are going to increment the j value. And yeah, obviously we are going to decrement the odd, the number of odds. If we are getting the that at position nums we are having a odd value, then we are going to decrement that. And definitely we are going to increment j value, and then I will be increased each and every time. And here we are going to add. Here have to take care of answer is equal to 0, and we are going to add all the counts inside answer after dealing with the odd numbers of k are done in this uh, while loop. After that we are going to return the value of answer. Okay, we have to make count is equal to 0 whenever we are getting that this number is going to be odd, and we have already dealt with the odd is equal to k before we have going to the another iteration. That's why we are going to make it as count is equal to 0. So this was the explanation. Let's run it. Okay, we have not defined I here. I is equal to 0. It got accepted for this number of test cases. This solution got accepted for these number of test cases given here, and let's submit it. Okay, it got accepted, and let's analyze it firstly with the given analyze complexity from the lead code, and then we will analyze from our side. It is giving big of n, and how it is coming big of n we are going to see in the solution. So here we are using I from 0 to n. That's why it is this while loop is taking a big of n only. And whenever we are getting this odd is equal to k, we are just incrementing the j value, and that's why it is not taking n square time complexity. It is just taking big of n. And this was the time complexity. When we are talking about the space complexity, this solution is not using any data structure to store values, so the space complexity is just big of 1. So this was about the solution. And yeah, thank you.